Assalamualaikum warahmatullahi ta'ala wabarakatuh and have a very good day. This is Structural Engineering Laboratory, CES 511, Shear Force in a Beam, Level 2. As an introduction, when a horizontal member of a structure, or known as a beam, is subjected to several concentrated forces or load and distributed load, it will bend due to shear force and bending moment. Shear force is the resultant forces in the beam acting perpendicular to its longitudinal x-axis. Shear force is an unaligned forces pushing one part of a body in one specific direction and the other part of the body in the opposite direction as shown in figure 1. Figure on the right shows the shear force equipment in our lab. It consists of the beam specimen and have two support, roller and pin support, and there is a load hanger in order for us to place the load and the cut section. It is also equipped with digital indicator. Generally, the summing forces in the vertical direction and also taking moment about the cut section for the left side. The formula shows how to determine the vertical forces of the specimen. In order for us to determine the internal forces of the specimen, we may use the force equation or summation of vertical force and using a moment equation. So figure 2 shows the sign convention for the internal forces and bending moment of the cutting section for the beam. In this experiment, there is two objectives. There are to show that the shear force at a cut section is equal to the algebraic sum of the forces acting to the left or right of the section. Second one is to examine how shear forces varies with an increasing point load. As the learning outcome, at the end of this experiment, students should be able to determine the value of shear force at a cut section with an increasing point load and draw the diagram of shear force and load applied. As a problem statement, in this experiment, in a beam design, shear and moment curve have to be constructed in order to determine the location of and magnitude of the maximum values of these forces. The proportion of the cross-section are determined by the magnitude of the maximum shear and moment in the span. The figure shows the shear and moment diagram for simply supported beam as your references. This is the experiment apparatus for shear force of the beam. This experiment is to determine the shear force at the cut section of this beam. Before that, I'm going to introduce the element of this apparatus. Here is the hanger for the load. Here is considered as a support A and support B. Here is the beam. Okay, here are the cut section of this beam. this apparatus is connected to this digital indicator. So as usual, to start this experiment, so you have to set the digital indicator into 0 value by press tab button. Then you have to place this hanger for the load at any position that you choose. In my case here, I'm going to choose 40 centimeter from the cutting section. So the reading, that we have to record is the reading of the forces or shear forces of this cutting section. Now we're going to apply load to this beam apparatus. I'm using 5 Newton of load and put at the hanger. Then I read the value of this shear force, which is 1.2 Newton. This value is showing the value of the shear force at this cutting section. Then we have to repeat this experiment for 5 times. I put another 5 Newton and the reading here is 2.5 Newton. So you have to record and tabulate the data. In this experiment, it is level 2 open-ended laboratory. Therefore, you have to find and obtain your own result for this experiment. Here are some of the information given based on this experiment, which is the specimen or the experimental setup. So the beam length is 950 mm. Distance of the cut section from the left support is 600 mm. And distance of a point load A from the support A is 300 mm. Based on this experiment, you have to find out your own data for this particular information and tabulate the data for at least 5 readings. So it should be include the experimental shear force at the cut section, and you have to determine the reaction of the beam. Furthermore, you also have to determine your own load with your own decision of the increment. Each group is required to prepare the experimental report based on the data that you obtain from any suitable references. In the analysis, you have to interpret the data, include all the analysis and calculation of the needed answer, and comment on the pattern of the graph, and state the relationship between shear force and forces applied. In the conclusion, you have to discuss about the result in your laboratory. In conclusion, you have to discuss about the result that you obtain in your laboratory result, and it should be reflecting with respect to objective of this study. As an application, there is several types of beam that we can design or we can use in our structural system, which are simply supported beam, overhanging beam, cantilever beam, continuous beam, beam fixed at one end and simply supported at the other end, and fixed beam. Each types of beam will give a different shape of shear force based on the load applied to the structure. That's it. Thank you.